Today we're working in Chapter 2, Lesson 7. We are on page 147. Our learning target today is that we will be able to find percents of numbers, and the content standards are use ratio and rate reasoning to solve real world and mathematical problems, and find a percent of a quantity as a rate per 100. So in a survey, 2,000 students chose their favorite snacks. Use the table to find the number of students who chose each snack. So the first row is done for us. The first row was the group of students who chose fruit as their snack. 23% of students chose fruit as their snack. 23% means 23 per 100. So 23 over 100. And then to get that as a number out of 200, to find out how many students out of 200, we're just doubling those two numbers, numerator and denominator. So we double the denominator times 2. So we need to double the numerator times 2. So 23 times 2 is 46. So 46 out of 200 students chose fruit as their snack. Moving on to cheese for the next row. 15% of students chose cheese as their snack. So 15% means 15 per 100. And again, to get from 100 to 200, we doubled it or multiplied by 2. So to get from 15 to our new numerator, we would double that as well. 15 times 2 would give us 30. So 30 out of 200 students chose cheese as their snack, so like a cheese stick or something cheesy. Vegetables. 17% of students chose vegetables as their snack. So 17% means 17 per 100. To get from 100 to 200, we doubled it. So to get from our numerator 17 to the new numerator, we also need to double that. So it would be 34 over 200, or 34 out of 200 students who chose vegetables as their snack. Next, cookies. 18% of students brought cookies, or excuse me, 15% of students brought cookies as their snack. So 15 out of 100. The equivalent fraction would be 30 out of 200. So 32 hundredths, or 30 out of 200 students brought cookies as a snack. Chips. 18% of students brought chips as a snack. So 18 out of 100 would be equivalent to, double both of the numerator and the denominator, 36 out of 200. So 36 out of 200 students chose chips as their snack. And then 12% of students did not choose a snack, so they are not snackers. So 12 out of 100 would be equivalent to 24 out of 200. So 24 out of 200 students did not bring a snack. And then as a check, when we're working with totals, we want to make sure that we are always making sure we got all of our data points. So we want to add up all those numbers in the last column to make sure that they total up to 200. So those numbers, we'll copy them down here into our list: 46 and 30 and 34 and 30, 36 and 24. So I'll show you two different strategies for adding these. First, the traditional algorithm, where we just add them up in a column: 46, 30, 34, 30, 36, and 24. 1, 2, 3, 4, 5, 6 numbers. 1, 2, 3, 4, 5, 6 numbers. Okay, and then we add our ones column. To focus that a little better. 6 plus 0 is 6, plus 4 is 10, plus 0 is still 10, plus 6 is 16, plus 4 is 20. Write the 0, carry the 2. 4 plus 2 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15, plus 3 is 18, plus 2 is 20. So 200. Okay, another strategy that you may have learned in elementary school is adding the tens first and then adding the ones next, and then adding those two sums together. So if I just add the tens column, 4 plus 3 is 7, plus 3 is 10, plus 3 is 13, plus 3 is 16, plus 2 is 18, but it wasn't 18. We were in the tens column, the tens place, so it's 180. So we just add the 0, multiply by 10. Then we can add our ones places together. 6 plus 0 is 6, plus 4 is 10, plus 0 is 10, plus 6 is 16, plus 4 is 20. So we had a 20 in our, when we add up our ones, and then we can add these together. 180 plus 20 is 200. So that's a little hybrid of mental math and then combining those together. So you can add those whichever way you prefer, or with mental math all together. How does finding the percent as a rate per 100 help you to find the number of responses for 200? So if we have the rate per 100, so if we have the rate as a percent, I should say, remember percent is out of 100. We have the rate as a percent, we can easily write it as a fraction over 100. So we can easily write it as a fraction with a denominator of 10. Denominator of 100, excuse me. Then multiply the numerator and denominator by 2. To find the rate per 200. Okay, so just scale that up from per 100 to per 200. Okay, go ahead and turn the page to 148, and we're going to start to learn how to find the percent of a number. So moving on to page 148. You can use fractions and decimals to find the percent of a number. To find the percent of a number, write the percent as a fraction with a denominator of 100, then multiply the fraction by the number. So here's another example. We have this circle representing the snacks that students at York Middle School chose as their snack of choice. So this middle school had 300 students, and we want to find the rate for each, or how many students chose each of these different snack items as their preferred choice. So here we have, they're asking us about the number of students who chose cheese as a snack out of 300 students, and then this is the way that the choices were distributed. Okay, so method 1, find the percent as a fraction. So when we look at cheese, we see that 15% of the students chose cheese as their snack. So really the question is this: what is 15% of 300? Okay, so honestly, I would do this with mental math. If I wanted to find 15% of 300, it's kind of like finding a 15% tip for something. You can find 10% very easily. 10% would be move our decimal one place to the left. That'd be 30. So 10% is 30. We know 5% is half of 10%. So if 10% is 30, then 5% is 15. So 10% plus 5% would give us a total. 30 plus 15 would give us 45. So we actually could do this one with mental math, with just a couple steps of mental math. But let's go ahead and do this with the algorithm, okay? So the question is 15% of 30, okay? So 15% of 30. All right, so for the first attempt, we're going to use fractions. So 15% means 15 per 100. Remember, cent means 100, So 100 cents in a dollar, 100 years in a century, 100 centimeters in a meter. So 15% means 15 per 100. Of means multiply. In math, of means multiply. If I said half of 10, you would do 1/2 times 10 and you would get 5. So remember, of in math means multiply. So 1500 times, now we're multiplying by fractions, so we need to write that 30 as a fraction. 30 as a fraction is just 30 over 1. Now I want to multiply those fractions. Before I do that, I want to check to see if I can make my problem simpler by cross canceling. So 15 and 1 cannot cross cancel, but 130 can. They are both divisible by 10. So 30 divided by 10 is 3, and 100 divided by 10 is 10. So we have 10, 15, here we go. Okay, so then we have so actually I made a little mistake right here. This is not 15% of 30, it was 15% of 300. So I'm just going to fix that right now. So it's 15% of 300. So not 30 over 1, it's 300 over 1. So again, that 15%, we would write it as 15 per 100 of means multiply, and it's 300 students total. So sorry about that mistake. Okay, so we want to cross cancel. We have 130, and those are both divisible by 100. Okay, so we can cross cancel. 100 divided by 100 is 1. And 300 divided by 100 is 3. So we just have 15 times 3, which is 45. And our denominator is just 1 times 1. So we don't really need to write over 1. We can just say 45 students. So 45 students had cheese as a snack. So now we'll do that same problem again, but we'll use our decimal for the problem. So it's the same thing. We want to find 15% of 300. So 15% written as a decimal is we drop the percent sign, move our decimal 2 places to the left. So it's 0.15 of means multiply, and then times 300. So 0.15 times 300, 0.15 times 300. So we multiply by 3. 3 times 5 is 15. Write the 5, carry the 1. 3 times 1 is 3, plus the 1 we carried is 4. So 3 times 15 is 45. But we were multiplying by 3. We were multiplying by 300. So we'll add on those 2 zeros. 0, 0. So 300 times 15 is 4,500. Okay, so, but it was not 15, it was 1,500. We had 1, 2 decimal places in our problem. So we need 1, 2 decimal places in our answer, so 45. So 45 students had cheese as a snack, whether we solve the problem with fractions or with decimals. So 45 students had cheese as a snack. Okay, letter A, find the number of students at York Middle School that have chips as a snack. So when we go back to our pie graph, we see that 18% of students chose chips as their snack. And remember, altogether, there were 300 students. So the question is, what is 18% of 300? So let's go ahead and do that. Zoom out a little bit. So 18% of 300. And since I know that percent means per 100, and I see this is a perfectly round 300, I know I'll be able to cross cancel if I write these as fractions. So I'm going to choose to write these as fractions. So 18% is going to, I'm going to write it as 18 over 100 of means multiply. And then I'll write my 300 as 300 over 1. Okay, then I look to see if I can cross cancel, which I already knew that I could. So that's the reason why I chose to write them as fractions. 100 and 300 are both divisible by 100. 100 goes into 100 one time. 100 goes into 300 3 times. So we have numerator times numerator. 18 times 3, that's 24. Carry the 2. 3 times 1 is 3, plus the 2 we carried is 5. So 18 times 3 is 54. Denominator times denominator is just 1 times 1, which is 1. So 54 students had chips as a snack. Okay, and then moving right on over to page 149. So we'll continue to do the same type of problem, except now we'll make our percentages just a little bit more difficult. We'll look at percents greater than 100% and percents less than 1%. So still, you may choose whether to write the percent as a fraction or as a decimal based on your preference and what the problem looks like. So number 2, we are asked to find 145% of 320. So this one's done for us. We can just walk through this process. We'll focus in on that a little bit. Find 145% of 320. So they work with fractions for this, which is a great choice. 145% can be written as 145 over 100. And then we can simplify that to 29 over 20. So these are both divisible by 5. When you divide by 5, that fraction simplifies to 29 over 20. Okay, then we write the multiplication problem. So instead of 100, so it's 145% of 320. So the 145% just got written as 29/20 of was written as times, then 320. So 29/20 times 320 over 1 when we write it as a fraction. Then we check to see if we can cross cancel. These are both divisible by 20. 20 goes into 20 one time. Remember, 20 goes into 100 5 times. So it would go into 300 15 times. And then one more 20 for the 320 would be 16. So this would cross cancel to 1 and 16. So that would give us numerator times numerator. 29 times 16 is 464. The denominator would just be 1 because we have a denominator of 1 times 1. So 145% of 320 is 464. Okay, moving on to number 3, and they set this up already for us with fractions. Okay. So number 3, find 200% of 65, or excuse me, 220% of 65. So 220% can be written as 220 over 100. Okay, and these are both divisible by 20. So if I divide by 20 here, I get 5. And if I divide by 20 in the numerator, 20 goes into 210 times and it goes into 21 times. So this is 11 times, so 11 fifths. So 220 over 100 can simplify to 11 fifths. So 220%, we're going to write that as 11 fifths of, we write that as multiply 65. And then as a fraction, we write that 11 fifths times 65 over 1. And then I check to see if I can cross cancel. 11 and 1 cannot be cross canceled, but 65 and 5 are both divisible by 5. Okay, 5 divided by 1 is 5. 65 divided by 5 is 13. So then we have numerator times numerator. 11 times 13. This gives us 143. Denominator times denominator is just 1 times 1. So it's just 143. 220% of 65 is 143. And that's a good, we can look at our number and see if it's a reasonable answer. Remember, 200% of something is doubling it. So if I doubled 60, that'd be 120. If I doubled the 5, that'd be 10, so 130. It was actually a little bit more than doubling. It was 20%. So that looks like a very reasonable answer, 143. Next, let's look at number 4, a percent less than 1%. A percent less than 1%. Find 0.25% of 58. So first of all, this wouldn't work really great as a percent, or excuse me, as a fraction, because that 58 is not really a convenient number to work with. So I would go with decimals, which they also went with decimals here. So find 0.25% of 58. This one's all worked out. So 0.25% written as a decimal, we drop the percent sign, move the decimal 2 places to the left, and put a 0 in there. So 0.0025. Of means multiply, then 58. So times 58. And they did the math for us to get 145,000. So 1/4 of 1% of 58 is 145,000. And then we can check for reasonableness in our answer. So 1/4%. Okay, that's obviously less than 1%. An easy way to find 1% is to move your decimal 2 places to the left. So here's my decimal. If I move it 2 places to the left, 1% would be 0.58. 1% would be 0.58. 1% would be 0.58. Okay, so 1/4% would obviously be 1/4 of this. So 0.145 times 4 would give us this number. So that's a very good answer. We don't need to crunch the numbers. We're just checking to see if it's reasonable. Next, letter B. Find 128% of 550. So for this one, I'm just going to work over on the side columns. Actually, I'll do it for B, for C, and for D, just so we have a little more workspace. For this one, I would probably work with fractions. Because I see I'm going to have a percent, so it's going to be over 100, and that's 550. Both of those numbers, I know I'm going to be able to cross cancel by 50. So for this one, I'm going to use fractions. So let's do letter B. Let's move to the top of the page on the right margin. We have some workspace there. So letter B is 128% of 550. So 128% is 128 per 100 of means multiply, and then 550, I'll write it as 550 over 1. So I look at these numbers and I can see they're both divisible by 50. Okay, so 100 and 550 can both be divided by 50. 100 divided by 50 will give me 2. 550, let's see, 50 would go into 500 10 times, and it goes into 51, so 11. So 50 goes into 550 11 times. So now my new problem, which I can simplify that first fraction, you might have noticed that already. 128 over 2 times 11 over 1. So 128 over 2, I see that half of 120 is 60. Half of 8 is 4. So 128 divided by 2 can actually be simplified to 64. So then we have 64 times 11. So I'll do that math over here. And they got 704. So the answer to B is 704. So 128% of 550 is 704. Then I want to check and make sure that answer is reasonable. It is a reasonable answer because 100% of 550 would be 550. 28%, 100 is like 1/4 of this amount. So that is approximately 200. That's pretty close. Okay, so it's a reasonable answer for sure. Letter C asks us to find 0.3% of 200. So for this one, I also would work with fractions because I see a nice round 200, and I know this is a per 100 or per over 100. So the 0.3%, 0.3% means the same thing as 0.3 per 100. Now, we know we would never leave an answer with a decimal within a fraction. That would not be simplified, but it's actually a very convenient middle step here, okay? So I can cross cancel that 200. So 0.3% means 0.3 per, that's our division line, our fraction bar, 100. Of means multiply, then I'll write my 200 as 200 over 1. Then I want to check and see if I can cross cancel. So I have 100 and 200. Those are both divisible by 100. So again, the 100 and 200, those are both divisible by 100. 100 divided by 100 is 1. 200 divided by 100 is 2. So we have 0.3 times 2, or 0.3 doubles, is 0.6. So 0.3% of 200 is 0.6. That makes sense. 0.3% of 100 would be 0.3. Doubles would give us the 0.6. So that is a very reasonable answer. 0.6. And then letter D, we have 0.85% of 600. And then I would use that same strategy again, 0.85%. So per 100, 0.85 per 100 or over 100 of means multiply. So I'll write that as the 600 is 600 over 1. Then I look to see if I can cross cancel, which I can. 100 is divisible by 100 to get 1. 600 is divisible by 100 and we get 6. So we have 8,500 times 6. 6 times 5 is 30. 6 times 8 is 48, plus the 3 we carried is 51. We had 1, 2 decimals in our problem, so we need 1, 2 decimals in our answer. So that would be 5.1. This one actually might have been easier to do as multiplication with decimals, but this is a good strategy too. So 5.1. Okay, and then we want to just check for reasonableness for our answer. 0.85% is pretty close to 1%. 1% we would find by moving our decimal 2 places to the left. If 1% is 6, then it's a reasonable answer to say that 0.85% is 5.1. So that is a reasonable answer. Okay, let's turn the page to 150. Number 5, in a recent state Special Olympics meet, Franklin County sent a team of 70 players. 20% of the team competed in soccer. How many athletes competed in soccer? So the question is, what is 20% of 70? Okay, so what is 20% of 70? Okay, so we're going to use a very different strategy here. We're going to find 10% and then double it because we're really good at finding 10%. So 10% would be, move our decimal 1 place to the left, 7. So 10% is 7. To get 20%, we just double it. So 14. So 14 members were soccer players. 14 members were soccer players. Then letter E, in the same meet, 15% of the team was from 15% of the team from Delaware County competed in tennis. If there were 20 members of the team, how many competed in tennis? Okay. So this is Delaware County. I think this is just a typo, Franklin County and Delaware County. So in the same meet, 15% of the team from Delaware County competed in tennis. We don't have any information, so I think these are both supposed to be Franklin. Okay, so 15% of the team competed in tennis. Okay. So that's actually not a typo, it's just a different set of numbers here, different data. So in the same meet, 15% of the team from Delaware County competed in tennis. If there were 20 members on the team total, how many competed in tennis? So this is what is 15% of 20, okay? So we can do that as a fraction or a decimal. Let's go ahead and do it as a percent. Let's go ahead as 15 per 100 of means multiply, and then that'll be 20. We can cross cancel here. 20 and 100 are both divisible by 20. We get 1 and 5. So that's 15/5, which we can simplify to 3. Okay, so 3 members of the Delaware County team competed in tennis. So 3 tennis players from Delaware County. Okay, so that was chapter 2, lesson 7, percent of a number.